All right. We took the Chapter 4 test yesterday, so we're moving on to Chapter 5 today. Put that away for me. Chapter 5, Section 1. Solving systems of linear equations by graphing. We're going to be graphing some today. You guys excited about that?
No.
100%. I like it.
I think I need to move up there.
No, it's okay. So let's get into the notes. Let's first talk about what a system of linear equations is. A system of linear equations is a set of two or more linear equations in the same variables. So there's two equations put together, one right on top of the other. They have the same variables. An example is shown below. So here is our system of equations right here. X plus y equals 7. 2x minus 3y equals negative 11. Those are both linear equations. They have the same variables, so that would be considered a system of linear equations. Everyone go with what a system of linear equations is. A solution of a system of linear equations in two variables is what? It is an ordered pair. That is a solution of each equation in the system. What kind of values make up an ordered pair?
An x value and a y value.
An x value and a y value. So for each of my system of equations, I need an x value and a y value. I've got to find both of them because it is an ordered pair. The ordered pair makes both equations true. So I'm going to have to check my answer quite a bit today. I got to plug into both equations, make sure that it makes it true. Any questions about a solution of a system of linear equations? We good? Can I move on, or are we still writing? Okay, I'll give you some time. Everyone got this down? Let's look at an example. Example 1, checking solutions. It says, tell whether the ordered pair is a solution of the system of linear equations. So how am I going to check this and tell whether it's a solution or not?
You plug in the ordered pair terms now.
Which one's my x value?
2.
Which one's my y value? Very good. So we're going to deal with x plus y equals 7 first. We said 2 is our x value, so I replace the x with 2. 5 is my y value, so I replace y with 5. Now I'm just working down both sides of the equation to see if it makes it a true statement. What's 2 plus 5?
7.
Does 7 indeed equal 7? It does. So it checks out for my first equation. I know that ordered pair is a solution to that equation. But I'm not done. What do I have to do next? Check the next equation as well. So replace my x with 2 once again. Replace my y with 5. We're working down both sides. 2 times 2.
4.
Negative 3 times 5. Negative 15. 4 minus 15. Does negative 11 equal negative 11? It does. So is this a solution to my system of equations? Yes. I can conclude that 2 comma 5 is a solution of the system. Any questions on example 1a? Does that make sense? On your assignment today, you do need to check your work. You need to check your solution into both equations to make sure it works. Okay? Can I erase and move to B?
Yes.
What's up? You say something? Okay. Example B. I'm doing the same thing. What's my x value now? Negative 2. What's my y value? 0. So y equals negative 2x minus 4. Replace the y with what? 0. Replace the x with? Negative 2. Negative 2 times negative 2. Positive 4. 4 minus 4. Does it work for my first equation? It is a solution of my first equation. Now I got to plug into the second equation. Replace the y with 0. Replace the x with negative 2 plus 4. Negative 2 plus 4. 2. Does 0 equal 2?
No.
It does not. So what can I conclude about negative 2, 0? Negative 2, 0 is not a solution of the system. Negative 2, 0 is a solution of my first equation, but looking at the system as a whole, it's not a solution of my system. Does that make sense?
Yeah.
Any questions there? Can I move on? All right. The solution of a system of linear equations is the point of intersection of the graphs of the equations. So that's how we're solving our systems of equations today, is by graphing. So there's our steps right there on how to graph, or how to solve by graphing. Step 1, graph each equation on the same graph. So we're graphing them on the same coordinate plane. Step 2, estimate the point of intersection. So look at the point where the two lines cross each other, where they intersect. We're going to call that point our solution. Step 3, we want to check that point to see if it works for both of our equations. Everyone good with that? So all the points on a line are a solution of that line. Does everyone agree with that statement?
Yeah.
Any ordered pair on a line is a solution of that linear equation. So that's why I want the intersection of the two lines, because I want the ordered pair where they're both the same, where it's a solution to both of them. So that'd be where they're crossing. I'll give you all a little bit to write. So our steps are pretty simple. Graph both equations, find the intersection point, check your solution. The intersection point is your solution. Can I go ahead and move on? Okay, I'll wait a little longer. Moving on to our next example. Solve the system of linear equations by graphing. So I got my system of equations. Y equals negative 2x plus 5. That's my first equation. Y equals 4x minus 1. That's my second equation. What does step 1 tell me to do?
Graph each equation in the same coordinate.
We're going to graph both equations on the same graph. So let's see if we remember how to graph using slope-intercept form. Is this slope-intercept form?
Yes.
Yes, it is. What do I graph first?
Graph your y.
My y-intercept. What's the y-intercept of equation 1?
5.
5. So I find 5 on my y-axis. Put a point. Everyone good with that?
Yes.
How do I get more points?
You turn the negative 2 into like you put a 1 in there.
So it's negative 2 over 1.
And since it's rise over run, you do down negative 2 and then over 1.
Very good. I use my slope. My slope's negative 2 here. So for slope purposes, that'd be negative 2 over 1. Like we said, we go down 2, right 1. Down 2, right 1. Which other two directions could I go?
Up 2, left 1.
Up 2, left 1.
Are you getting a 1 from the x?
Just negative 2. Any whole number to make it a fraction, you put it over 1. So since negative 2 is an integer, it's like a whole number, put it over 1, that's a fraction. So I'm going to go down 2. From my y-intercept, right 1. Down 2, right 1. I want you to get as many points on the graph as you can. So keep going until you're off the graph. So we went down 2, right 1. Now I can go up to left 1. Connect my points. There's the graph of equation 1. Any questions on that?
No.
I want to remember graphing. What's the y-intercept of equation 2? Negative 1. Put a point at your y-intercept. Negative 1. What's my slope in this case?
We go up or left, or we right down.
Up 4, right 1. It's 4 over 1. From my y-intercept, 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. And then I can't go up 4 anymore. So I'm going to go which two directions now?
Or left one.
Down 4, left 1. Connect my points. There's my graph of equation 2. Sorry, it's not that straight. Try to make your lines straighter than that. Any questions on how we're graphing? Okay, what does step 2 say to do?
Estimate the point of intersection.
So where do we think these points or these graphs are intersecting?
1 and 3 wins.
1, 3.
1, comma 3.
1, 3.
It'd be this point right here, correct? 1, comma 3. That's where the graphs are crossing each other. So we're going to say that 1, 3 is our solution. What does step 3 say to do?
Check the point from step 2 by substituting x and y.
So I'm going to check my point into both of my equations. So my first equation, y equals negative 2x plus 5. What's my y value that I'm plugging in? 3. What's my x value? Negative 2 times 1?
Negative 2.
Negative 2 plus 5.
3.
Does 3 equal 3? Yes, it does. Checks out for my first equation. Everyone with me? Okay. Y equals 4x minus 1. What's the y value I'm plugging in?
3.
And what's the x value? 4 times 1?
4.
4 minus 1. Does 3 equal 3? It does check out for my second equation. So I know 1 comma 3 is my solution of my system of equations. Any questions on that? Not too bad? Pretty easy. Graph the two equations. Find where they intersect. Check that point. Good with that? Okay. This is our last slide, but I did want to show you two more things real quick. I'm going to use this graph. Let's say I gave you the equations y equals 3x plus 4, y equals 3x minus 3. Let's graph our first equation. What's the y-intercept? 4. What's my slope?
3 over 1.
Up 3, right 1. Wait, that's wrong. We're up 3, right 1. Up 3, right 1. I can go down 3, left 1. Down 3, left 1. So on and so forth, so I can't get any more points. There's the graph of equation 1. Questions on it? All right. What is the y-intercept of equation 2? What? Negative 3. So put a point at my y-intercept. What's my slope? 3 over 1. Of 3 over 1. What do we notice about these lines?
They're not
They're parallel.
They're parallel. Could I have known they were parallel before I graphed them?
Yes.
Why?
They're
The same slope.
They have the same slope. So, remember, the solution of a system of equations is where the lines intersect. Are parallel lines ever going to intersect? So, if the solution is where they intersect, and they never intersect, what's my answer going to be? What's my solution? No solution, or you can write the no solution symbol.
Wait, so on the worksheet, say this one of these questions come up and they have the same, so we don't have to graph it out or anything?
I still want you to graph it, but all you got to do is tell me no solution. You don't have to check anything. So graph them, tell me no solution. Okay? Does that make sense, though, as to why it's not a solution? There is not a solution. These lines are never going to touch, so there's not a solution to this system of equations. There's infinite number of solutions to each line separately, but together as a system, there's not a solution at all. Everyone good with that? Okay, one more. You'll be okay. We're almost done.
Alright, can we choose the thing?
Nope. Choose the black ink. Y equals, let's do negative x plus 3. X plus y equals 3. So our first line's in slope-intercept form, correct? What about our second line?
It's not.
No, how would I get that in slope-intercept form?
You divide x by x and
Not divide.
You subtract
subtract x.
Subtract x from both sides. What do I get?
Y equals x minus a negative x plus 3.
What do we notice about those?
Isn't slope-intercept?
They have the same slope.
They're the same.
It's gonna be
They're the same line, right?
yeah.
They're the same exact equation. Let's graph it real quick. Y-intercept,
1,
3.
3.
Slope,
down
down 1, right 1. Or I can go up 1, left 1. So there's equation 1. If I graph equation 2,
It's gonna be the same.
it's going to be right on top of it. Correct? Same exact line. Okay, let's think about this real quick. The solution to a system of equations is where the graphs intersect, correct?
So the
Are these graphing any, or are these intersecting anywhere?
must be all real numbers.
We're not going to say all real numbers.
Okay, hold on. No, they're not intersecting anywhere, they're just over top.
They're intersecting everywhere. At every point. Every point, they're intersecting. They're crossing. They're touching. Right? Infinitely many solutions.
Yeah, can we just use the
Nope. You can write out 3 measly words. Infinitely many solutions. Write that out. Don't put IMS. Don't put the infinity symbol. Don't put anything like that. Infinitely many solutions. Just like that. That's what I want. Infinitely many solutions. Just like that. That's what I want. Okay? Every ordered pair on this line is a solution to both of my equations. So I don't have to check anything because I'd have to check every single one of those if I started checking, which is an infinite number of solutions. Does that make sense? So if you get the same line, it's the same, or if you get the same equation, it's the same line, one on top of the other. Infinitely many solutions. If you get parallel lines, they're never going to touch, no solution. If you get 2 regular lines where they're crossing once, you get 1 solution. Any questions on that? I don't think you'll see any like that today on today's assignment, but tomorrow with the sub, I'm going to throw some on the assignment. I'll explain that in a second. Tomorrow on the assignment with the sub, you will see some similar to this. So I wanted you to be prepared for it. Are there any questions? Can I move on? Here's our assignment. Page 231, numbers 2 through 22, evens. This will be due on Monday, May 3rd, on Canvas. Saturday is May. That's crazy. It's moving along. So usually I have the assignment due 2 days after, but we're not in school on Friday at all. It's not a virtual day. We're just off. So this will be due on Monday. Anyone good with that? Any questions before I end my recording?